In previous video, I showed this damn nice time-lapse of printing on my Prusa MK4S 3D printer. However, there is a lot of effort and frustration beyond this footage. In today's video, I will show you all the things I had to deal with and what I came across on the way to create this footage. As I said at the beginning, this video will cover the creation of time-lapse videos from printing on the Prusa MK4S 3D printer. However, it will mainly cover the configuration of the Prusa Slicer and info on what to look out for. It will not cover examples of used photo and video equipment, nor the creation of the final video. I'm already preparing other videos covering this topic, but they need a little more time to be perfect. But no more time wasting. Let's take a look at the basics of creating a time-lapse video. Basically, it's nothing complicated. Ordinary video footage captures a certain number of frames per second. For example, I usually shoot at 25 frames per second. If I wanted to show you, for example, this approximately half-hour long print, most of you would walk away after the first few seconds. However, if I could reduce this entire video to a few seconds, you wouldn't miss anything and the entire video wouldn't take minutes or hours. One option is just to speed up the entire print footage in a video editor. However, with a printer with a moving bed, this creates a messy video that is not very pleasant to watch. The magic of time-lapse footage is the fact that it doesn't capture every frame, but just a frame every few seconds or minutes, for example. Using simple mathematics, we can calculate that a half-hour long print would contain 45,000 frames at 25 frames per second. However, if I only took a frame every second, my video would contain 1,800 frames. A video footage of these 1,800 frames at 25 frames per second would take only 72 seconds, aka 1 minute and 12 seconds. It would still be such a messy video, but a 1 minute and 12 second long video is already watchable and it takes up significantly less disk space than a file containing video footage of an entire print. For smooth time-lapse footage, you need to keep the recording device in a stable position and change as few things as possible in the field of view of the device. In 3D printing, this involves, for example, stable lighting in the printer area and an unchanging position of the print during the image capturing process. Which is easy to say, but hard to do with a 3D printer with a moving bed. This actually brings us to my story and the main topic of today's video. With 3D printing, you can use, for example, a transition to a new layer to capture the frame for time-lapse footage. This reduces the number of frames in the video according to the number of layers in the print. For this model with a layer height of 0.2 mm, I have a total of 240 layers. At 25 frames per second, this is almost 10 seconds long video. If I increase the layer height to 0.25 mm, for example, the print would have a total of 192 layers. At 25 frames per second, the video would be less than 8 seconds long. As you can see, the video is fast and you can see everything important. In addition, the final video file requires a minimum of disk space. Unfortunately, the moving bed makes the video very unpleasant to watch. Therefore, I tried adding G-code in the slicer after changing the layer to move the print head to the right corner and bring the print forward. This should make the printer look as if it hasn't moved since the last frame on every shot. Except for the Z-axis, of course. Unfortunately, my expectations were met with great disappointment. The movement speed was faster than the frame capture speed. So I tried adding a command to the G-code after the layer change that waits 500 milliseconds after the movements are complete. I put this command before, but also after the commands that capture the frame. That pause before capturing the frame will ensure that the printer and possibly the recording device will stabilize on an unstable surface, as in my case. The printer parks the axis at the specified position, waits half a second, sends the command to capture the frame, waits half a second, and only then continues printing. As you can see, the footage now looks as expected. On the footage, it looks like the print is growing right in front of our eyes. The more observant among you must have noticed the stringing of the filament as the print head leaves the model. This stringing left very visible artifacts on the model. I chose PTG for this print on purpose, because wet PTG is well known for stringing. If you thought you were going to print only from PLA and not have to deal with these problems, I am sorry to disappoint you. PLA doesn't like the nozzle to go away from the print either, and you can see it too on the final print. So I started thinking about how best to tell the printer that it should maintain filament pressure in the nozzle and prevent material from leaking out on its own. This is handled for the printer by the slicer, which can optimize the nozzle pressure as it moves between objects. That's why I had the idea of placing a second object on the print pad, where the nozzle waits for the frame to be captured. For this object, I chose an ordinary 16mm diameter cylinder, which I named time-lapse, and placed it at position X241 and Y201. This is because the print head remains in this position after the print is finished. I set the height of the cylinder according to the height of the printed object, which in my case was 48mm. I set the infill of the model to a grid with a density of 5%, which gives me a cross in the middle of the model. The nozzle stays parked on it while waiting for the frame to be captured, and since it touches the object, there is no risk of any material leaking out of the nozzle. I set the cylinder perimeters to 2, I hit the transition to the new layer on the back of the model, and I deleted the top layers. It was also important to have this object printed as the last one. With 2 objects on the print pad, just move our cylinder to the end of the list. With multiple objects, it helps to merge all the older models into one group and move our cylinder to the end of the list. Always use the slider to check that the model will indeed be printed as the last one. I did notice one weird thing while printing. The printer printed both objects, but didn't wait on that cylinder. Instead, it went to the main model. However, it immediately returned it to the cylinder, where it paused and triggered a command to capture the frame. After a moment of scrolling through the G-code, I figured out the reason. The slicer on some filaments, PETG being one of them, performs a cleaning movement of the nozzle before moving to another object. In order to preserve the default logic in the slicer and in the individual filament profiles, I decided to capture the frame before moving to a new layer. However, this put me in a situation where I don't have the frame of the last layer. Therefore, I moved the entire G-code to the template section with its own G-code. This gave me the ability to use this G-code in multiple places using the template custom G-code variable. I put this variable in the section before moving to a new layer and before the end of the print. Now everything was behaving exactly as it should. It really looks like only the Z-axis is moving on the printer and the model is growing right in front of us. Looking at the model more closely, we shouldn't find any flaws in it caused by the pausing to capture individual frames. If you are bothered by the cylinder or print head in view, just position the recording device so that these objects are not in the view. If you are interested in learning how to create the resulting time-lapse videos using your mobile phone or using your camera together with the Prusa GPIO hacker board, subscribe and stay tuned for the next video.